So we need to determine whether each series converges or diverges. So let's look at the very first one. So when I'm kind of at a loss of which test to use, I always have two ones. I have the nth term test and the ratio test. In this case, I'm going to use the ratio test. So those are the two ones that I always try first. So I'm going to have the nth plus 1 term. Notice that for this one is 2 times the nth plus 1 term, okay, divided by the nth term. So if I write, okay, so this is the same thing as n plus 1 times n minus 1. And then the bottom one, notice that I distribute the 2. So I'm going to have 2n plus 2. So my n's cancel. So this one, when I rewrite it, I can rewrite it as 2n plus 2, 2n plus 1, 2n factorial, because that's what I want to cancel. So I'm left with this series. Well, since n is going to infinity, this is similar to n over 4n squared. Remember, we're looking at the highest power numerator, highest power in the denominator, which is 1 over 4n. So this is going to 0. Because 0 is less than 1, this converges by the ratio test. Okay. For part B, since it's 2 to the n, the first thing that I would try to do is I would do the ratio test. And if you guys remember, the ratio test is we're taking the square root of n, because then my n's cancel out and I'm left with 1 plus 1 over 5n squared. And as n goes to infinity, this is getting closer and closer to 1, so I'm left with 1 squared. But when it's equal to 1, the root test doesn't work. It's inconclusive. So I have to use a different test. Okay. So one of the things that I look is, I find this is familiar from last chapter when we were doing L'Hopital's rule to the nth power. And my answer always ended up e to the something. Okay. So that means it's not equal to 0. So I'm going to be able to use the nth term test. Because if it's not equal to 0, then it's automatically going to diverge. And if you look at the graph of this is growing exponentially, so it's going to diverge. So what we're going to do is we're going to take the limit as n goes to infinity. So we're going to use L'Hopital's rule. Okay, we're going to use that trick. Since it's 2 to the n, I want to move that to the front. So I'm going to write e to the ln. So I can put the 2n to the front. So because it's going to infinity, I want it to either be 0 over 0 or infinity over infinity. And now I can use L'Hopital's rule. So this is the same problem that we did last time. The 1 over n squares are going to cancel. So I'm left with e to the 5/2, which is not equal to 0, so this diverges by the nth term test. The last one, I'm going to use the comparison test. I'm going to compare it to 1 over the square root of n. And I'm going to use the limit comparison test because I'm not sure which one's bigger, so it's just easier for me to use the limit comparison test. So it's the one I'm comparing, or the original divided by the one I'm comparing. So this is similar to the square root of n over the square root of n, which is equal to 1. Okay. And this is a p series which diverges. So remember the limit comparison test, they're either both diverge or they both converge. So this is going to diverge.